So what we're going to do today is we're going to learn two methods. There's three methods in which you can solve linear equations. Now, to begin with, these are the two methods that I'm going to show you are going to be very important to you going ahead, because as we speak in grade 11 pre-calculus right now, we're using these methods in order to solve linear and quadratic equations. Hello? Yeah, sure. Hello? All right. No, they should be on the table. Okay, they're just going to the staff room and they're on the shelf where I usually put my jacket. That's in the middle of a lesson here, so, but they're there. You can grab them and unlock the truck and so you can key them in there. Okay, so, okay, so back to what I was saying here. There are three methods in which we can solve this to find out whether we have one intersection point, whether we have parallel lines, so there's no intersection points, and we have a coincidental line, which is an infinite number of intersection points. Okay, so there's three methods. Method number one is the graphing method. We just spent the entire chapter 8 doing graphing. Okay? Method number two is the one that we are looking at today, which is solving systems using the substitution method. Okay? So, we have two equations here and we want to solve them. So, again, you have your graphing apps. They can help you solve this. However, in order to get full marks, you will have to show your work on how to do both methods that I'm going to show you, the substitution and elimination method. But you should check every one of your answers as you go through using your graphing method. All right, so substitution method works like this. I pick the equation. I have two equations here. They may intersect, they may not, but we're going to find out. So what I want to do is I want to use one of the equations and isolate one of the variables. So I want to get either x or y by itself. Now personally, I picked the one equation that has the variable that has a 1 in front of it. So which of the equations has a variable in which you have a 1 in front of it? The first equation, and which one has the 1 in front? The y. So let's isolate the y now. Okay? So I'm going to use equation A to isolate y. Y is equal to, how do I get y by itself? Take away 5x. So minus 5x, add 11. So I've isolated that. Everybody okay with that? Now what I'm going to do is I'm going to substitute minus 5x plus 11 into the second equation for y. That is going to give me one variable only. So I take equation B, 2x plus 3. Now instead of y, I'm going to put in minus 5x add 11 equals 7. Okay? Open your scribbler and write this down. Is it easier for you to follow on the board?
Well, I'm paying attention to the board.
Is that easier for you?
Yeah, but I'll still take notes because I need to.
Okay. All right. So now, what do you notice about equation B?
Get that to the same.
Yeah, I'm down to one variable, am I not? I'm down to just x. So now I can solve for x. Okay? So the first thing I do is I get rid of my brackets. Minus 15x plus 33 equals 7. So far so good. I multiplied 3 through the brackets. 3 times minus 5x, 3 times 11. We okay so far? So what do you suggest I do next? Yeah, I like exactly, you're saying the same thing, but I really like what you said. Gather the like terms, that's awesome. Okay, so 2x subtract 15x is what? Negative 13x. Add 33 equals 7. So now I need to isolate my I need to isolate my x. I'm 2 steps away from isolating x. What's the first step? Subtract 33. Minus 13x equals minus 26. What's my last step then? Divide by minus 13. Very good. X is equal to 2. Okay? Alright, so I have the x coordinate of my intersection point. Now I need the y coordinate. You can choose either equation to do this now. So let's do that. I'm going to use equation A. 5 times my x value, which is 2, plus y equals 11. What's 5 times 2? 10. 10 add y equals 11. How do I get y by itself? Take away 10. Y is equal to 1. What's my coordinate where they intersect? 2 and 1. So now, I graph them. Find out if my intersection point is 2 and 1. Or, let me do you one better. I'm going to put 2 and 1 into the second equation. And if it works, the left side should equal the right side. So 2 times 2 plus 3 times 1 should equal 7. 2 times 2?
4.
3 times 1? 3 plus 4? I got the right answer. You can guarantee your work every single time. Every time. There should be no excuse for you not to get 100%. Unless you don't know the actual methods to do this, okay? But this is the substitution method. So let's look back at how we started this question again. I have both equations down and I designate them A and B. What was I looking for?
1 value. X.
Yeah, one of the variables that has a 1 in front of it. Okay? Whether it's X or Y. And then after I decided that I was going to use equation A, which value did I isolate? I isolated my Y. So I got it as Y equals negative 5x plus 11. Then what did I do with it once I isolated Y? Substituted in to the second equation, the B equation, for Y. So 2x plus 3, and then I put in negative 5x plus 11, which equals 7. And then solve for x. Once I had x, what did I do next? Substitute it into one of the two equations. It doesn't have to be, it can be either equation to solve for y. Got it? Okay, any questions? Seems easy, right? You've got a phone on. Shut it off, please. Okay. So, first thing I look for,
Y value, or any value of 1 in front.
are any of the values have a 1 in front of it? No. Okay. So that's not as much fun, but we have to deal with it. Okay, so next thing that we are going to do then is we are still going to isolate one of the variables. You can pick whichever variable you want. All right. What do you suppose the easiest variable would be to isolate in this case? 2y. Okay. Anybody else want to offer up a suggestion?
4x.
How come?
It's already different.
Yes. Yeah, that would be the one I go with. Okay? Is the 4x, because I've already made one of the movements has already happened. So what do I have to do to get x by itself there? Divide by 4, right? Okay, so let's do that. I like that idea. 2y is not wrong. None of them are wrong. In all honesty, you can isolate any one of the variables. Okay? But that's the one I'm going to do. So, how do I get x by itself here? Divide by 4. So I'm going to get x is equal to 3 minus 5 over 4 y. So it's not ideal because we have a fraction, but we'll work with it. So I've used equation B to isolate. So now I need to plug it into equation A. So where I have x in equation A, I'm going to put 3 minus 5y, 5 over 4y. This. Okay. What's the next step? Yes. Get rid of the brackets by multiplying by 3. So 9 minus 15 over 4 y plus 2y equals 2. All right, any suggestions right now? Because the next thing was to collect the like terms, right? But what do you see as an issue here? I have a fraction. I don't personally want to work with fractions here. So how can I get this equation so that I don't work with the fraction?
Put 2 over 1 and find a common.
No.
Okay.
Yes, I do. Yes, I do. Okay? I want to multiply everything by 4. That way I get rid of the denominator on the bottom. So 9 times 4 is 36. When I times this by 4, the 4 is going to cancel and leave me with minus 15y. 2 times 4, 8y equals 8. So, times by 4, times by 4, times by 4, times by 4. That 4 and that 4 cancel. That was my goal. Does everybody see that step? Everybody see that step? Anybody not see it so I can explain it? Okay? All right. So now I'm going to collect the like terms. 36 minus 7y equals 8. How do I get 7y by itself? What's the first thing I should do? Subtract 36, so minus 7y equals, what's that? Minus 28. Now what? Y equals 4. Okay? I have the y value of my intersection point, right? What do I need to do next?
y
A little louder, please, Dylan.
plus the y into another equation, or the second equation.
Doesn't matter. I need to now find my x value, correct? So I gotta plug y into one of these equations right here. It doesn't matter which one. So I'll use a. So I've got 3x plus 2 times 4 equals 2. 2 times 4. What do I do now? Subtract 8. Then divide by 3. X equals 2. What's my intersection point? 2 and 4. I can substitute that in here.
Does it matter in the end which one you substitute in?
No. I got a problem here. Right here. Yeah. -6, which makes that a -2, which makes that a -2, which makes that a 2. Good. Good, good, good. Okay. What's 4 times -2? -8. 5 times 4? 20. 12 subtract 20? You got it right. Okay? Any questions about this? None? So this part right here is just a proof in which you're going to use your calculator for anyways. Okay? How are we doing so far? Now, because I've got people missing tomorrow, I'm going to show you the second method. So I'll come back to this one again, but I'm going to use the second. I'm going to do the second method right now. Okay? Which will confuse some of you. I do believe that'll happen, but I will help you fix that in a second. The second method is called the elimination method. Don't turn to it in your book. I'm just going to do it on the board using the same questions I've already done. Okay. So we've already done this equation, this question, right? So the beauty of this is that it's only the start of this that's different. You only approach the very first part of it to get that first half the first variable by itself. That's all that's different. The rest of it is done the same. To get your second variable, you substitute in and get it the same way you did with substitution. But this one, people find tricky. So I'll try my best to make as much sense as possible. All right. What I want to do is I want to either add or subtract. Now I never ever subtract, for the record. So I'm just going to use add. I want to add these two equations together so that one of the variables cancels out. I'm going to eliminate one variable from these two equations in order to solve this question. Again, I'm shooting for the intersection point. Okay? So here's what needs to be done. I'm going to multiply one of the equations by a value such that I can cancel out one of the variables by adding to it. Now, it doesn't seem like it makes a lot of sense right now, so I'm going to explain it to you. Again, I look for the variable that has the 1 as a coefficient if I can. It makes it easiest. So this guy has a 1 in front of it, right? What would I have to multiply this guy by in order to add it to this and get 0? -3. So that's what I'm going to do. I'm going to multiply everything in that first equation by -3. Like that. So that equation becomes minus 15x minus 3y equals minus 33. 2x plus 3y equals 7. Okay? All right? Now you're going to hear words, so I'm going to say this, additive, inverse, conjugate. All I'm saying to you is I want to match them up so that when I add them together, one of them becomes 0. Okay? So we're going to get good at this. This is going to take about 5 minutes and we'll be really good at this. All right, so now I've got these equations written the way I want them. Let's add them together and see what happens. What's minus 15x add 2x? Minus 13x. What's minus 3y add 3y? 0. I cancel it out already. What's minus 33 plus 7? Minus 26. I've got to get x by itself. What do I do? Divide by negative 13. What do I get? 2. I'm done. Not bad, right? Not bad at all. Okay? So now, how do I get the y value again? Put it into one of the two equations. Doesn't matter which one. It's exactly the same thing we did in the last method, right? So let's put it in. 5 times 2 plus y equals 11. I use the original equation always. What's 5 times 2? And when I subtract 10 to the other side, what do I get? 1. I'm done. It seems a lot less work, doesn't it? Right? But all I did was start the question differently and still ended up with the same solution. Still ended up with 2 and 1 the exact same way I did the last one, right? So let's go back to this. Here's the substitution question. I substituted in, I did all this work, I got x equals 2, and then I did the exact same thing to get y. Alright? It's not complicated. It's not complicated. Now, my question to you. Let's say I didn't want to cancel the y's out. Let's say I wanted to cancel the x's out. What could I do so that I got one x as a positive and one as a negative so that I can cancel them out? What would I multiply them by? Any ideas? Go ahead. 5 and 2. Which one am I going to multiply by 5? The b, right? I times this by 5, then I might times this by negative 2. That would give me negative 10x and 10x. You can use either one you want and still get it. So let me show you that just so that you trust what I'm saying here. So what is it? 5x plus y equals 11, right? And b was 2x plus 3y equals 7, right? So here's what I can do. I'm just going to start this. I'm going to times a by minus 2, and I'm timesing b by 5. That gives me negative 10x, negative 2y equals negative 22. 10x plus 15y equals 35. Okay? TJ, watch this, please. All right? So now what happens? When I add them together, what's canceling out this time? The x's are, right? That and that is 0. Gives me 13y here, right? Add those together, gives me 13. Y is equal to 1. So you can do whichever ones you want for your variables. Now what do? Put that back into my equation and solve for x. Okay? So I'm going to show you this next one here. 3x plus 2y, because there's a catch to this. 3x plus 2y equals 2. And then we have 4x equals 12 minus 5y. Okay. For me? What'd you say? Because I think you're right. Yeah, we want to make sure that we get it in the same form. Right now I have ax plus by equals c in A. In B I don't, so I want to do that first. So I'm going to switch these equations first. 3x plus 2y equals 2. B, 4x plus 5y equals 12. Okay. So how do I get this? What do I multiply A by, and what do I multiply B by so I can cancel out? Yes. So times this guy by -4, you said? And times this guy by 3. Awesome. What else could you do? Go ahead. Times the first one by -5 and the second one by 2. Works. Both will work. So A, that's minus 12x minus 8y equals -8. B is 12x plus 15y equals 36. Seth, watch. Okay, what's canceling out here? Oh, x is, what's minus 8y plus 15y? 7y. What's minus 8 add 36? 28. Good job, Dylan. What does y equal? 4. What do I do with the 4 now? Put it into one of the equations. 3x plus 2 times 4 equals 2. 3x plus 8 equals 2. 3x equals what is it? That's what I did wrong the first time. -6. Right? Subtracting 8. X equals -2. -2 and 4. Okay? Just the start of the 2. In substitution method, you isolate one of the variables. In the elimination method, you get the equation so that one of the variables adds to the other to get 0. That's all there is to it. And what am I checking my answers with? Nope. Say what?
From the two coordinates into the
What's the easier way to do it?
Graph it.
Graph it. Graph it on your app. Okay? That's the easiest way to do it. But yes, I could plug the coordinates into the second equation, the one that I didn't use, and that would work. Okay? Any questions about this? So, your focus in 9 is on the substitution method, the elimination method, and you're still going to do the graphing. Alright, and that's it. Basically all there is to it. Okay? So you'll have 9-1 and 9-2 today. I think there's a 9-3, it'll be problem solving. Yeah. Problem solving will take a day or two because you're going to have to write your own equations out, which is where everybody struggles. And then we'll review, and then you're done. Start studying for your exam. Okay, any questions? Yes. Oh, Shouldn't be much. Okay, you can go to work on that. I'm gonna hand out your tests. You've got a few minutes to do your tests.